Hey everybody, Mr. Piercy here, and we're going to be looking at similarity today, but specifically we're going to be looking at how similarity can be applied to triangles. So earlier in our curriculum we discussed the idea of triangle congruency, and we had side, 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 angle, side, etc. And out of the acronyms that we had, the little, side, side, side for, as we'd say, SSS, well, there were two combinations of parts that didn't work. Side-side angle doesn't work because if the angle is not included in between the two sides, we could actually get two different triangles as opposed to two triangles that are congruent to each other. And that will come back again later on when we're talking about trigonometry, maybe not in geometry, but in trigonometry and pre-cal, you'll see that again as a special case with something called the law of sines. But the other thing that we talked about, this combination of parts that we said didn't work, was angle, angle, angle. And the reason why we said it doesn't show congruency, it shows similarity, what I would have used at the time is I would have said, well, I could have an equilateral triangle where this is 5 and all of the angles are the same, and I could have another one where this is 7 but all of these angles are still the same because every equilateral triangle, all the angles are always 60 degrees. However, the triangles that we would have would be similar to each other, so angle, angle, angle doesn't show congruency, however it does show similarity. And we don't even need all three angles. If we can show two angles are the same, well, the third angles theorem says that the third angle also has to be the same because there's only 180 degrees of the three interior angles of a triangle. So if we can show that two corresponding angles are congruent to each other from one triangle to the next, then we have enough information to justify that the triangles will actually be similar to each other. So here we see angle J is congruent to angle X, angle K is congruent to angle Y. So because of those, angle L and angle Z will also be congruent to each other, and that is enough to let me say triangle JKL is similar to triangle XYZ. So this is what we're going to be looking at today, is trying to justify or trying to identify, do I have two corresponding congruent angles in different triangles, so that way I can show that they're congruent to each other or not, or are similar to each other, I should say. Pardon me. So here's a pretty typical example of the types of problems you might be looking at. We have two triangles ABC and triangle DEF, and we want to know, are the triangles similar to each other or not, and be able to explain why it is or why it is not. So looking at the figure here, let's go ahead and fill in the blanks, because quite honestly, the way that they're showing you how to work it out is a little different than the way my brain works when I'm looking at these. But here, they are going to show that, pardon me, we do have two angles, B and E. They're right angles, so they have to be congruent to each other, because that was one of Euclid's first 5 postulates that he wrote all of geometry about, was that all right angles are the same. So, by the triangle sum theorem, the two angles that we know, 68 and 90, have to have a sum of 180. So therefore, the measurement of angle A is 22 degrees. So that means angle A and angle D are congruent to each other. So the triangles must be similar to each other by the angle-angle similarity postulate. Now, I would have looked at it pretty much the same way, but I would have taken a different view on it. I wouldn't have necessarily said that, all three angles have to add up to be a sum of 180 degrees. What I would have said is I would have looked at it as the measurement of angle A has to be the difference, because the two acute angles of a right triangle have to be complementary to each other. So I would have said the measurement of angle A is simply 90 minus the 68, and shown that the measurement of angle A was 22 degrees that way. And then I would have been able to say, well, take your pick. I have the 90 degree at angle B. I have a 22 degrees at angle A. So there's two angles that are congruent to each other. So therefore, the figures must be similar to each other. So down here in problems in the checkpoint, problems 1 and 2, it's basically the same thing. Determine whether the triangles are similar to each other or not, and if they are, write a similarity statement. And remember, a similarity statement is just something like that where we say some figure with that single wavy line and another figure. That's a similarity statement. So go ahead and pause the video and answer checkpoint questions 1 and 2, and when you're done, hit play again and come back and see what I wrote down as my answers. Okay guys, let's see. So hopefully we have a couple of good answers here to look at. Now looking at the figures here in the two triangles in example 1, I'm going to look and see, well, the third angle of the small triangle, angle H, is 71 degrees. So because I can say that this angle here is 71, I have another angle here that's 71 that corresponds to it, and R and F correspond to each other, so we do have two corresponding congruent angles, so that is enough information for me to say that the triangles are similar to each other, and so I said triangle QPR is similar to triangle GHF. So for the next one here, looking at the same thing, I'm trying to find the measurement of angle Q. I didn't have to find Q, I could have found F, but I chose to find Q. And since I did, I showed that angle Q is 100 degrees. Well, if this angle here is 100 degrees, then I don't have two sets of corresponding angles that are congruent to each other. I do have one. I have H and P that are congruent to each other, but because G and Q are not the same, then that means that R and F will also not be the same. So we only have one set of angles that are congruent and not two. So there's not enough information. We cannot say that these triangles are similar to each other. Now looking at this one here, we're going to kind of start combining figures together, looking at them, and we want to be able to make sure we're going to be tying in some older concepts with this stuff, some previously used skills. We want to show that the triangles are similar to each other. So I'm letting you know at the outset, or the authors of the material are, that the triangles are similar to each other. You just need to be able to justify why are they similar. Well, looking at the diagram in A, what it does say is that you might find it helpful to redraw the triangles. Now, if you want to, you're perfectly welcome to, and you would have something that looks like this. We'd have R, T, V, like that, and then I'd have another bigger triangle where I have R, Q, S. Personally, I think it's actually better to leave them together, but if you need to see them drawn separately, there they are. Now, the reason why I think it's easier to identify whether the figures are similar to each other or not, leaving them together, is because here at angle R, it's easy to see that R is used in both figures. Now, it is obviously easy to see here that R is used, the same angle is used in both figures, but to me, it just is, maybe because I've been doing geometry for so long, it just makes sense that, well, if two figures are using the same angle in this case, they need to overlap. And so that's why I would kind of look at them as just leaving them the same. But if you need to, go ahead and draw them separately. And let's go ahead and put the angles here, 49, 9, and 49. So what they're saying is because angle T and angle Q and angle RTV, because those are the same, well, that's one set of corresponding angles. Well, even though we don't know the measurement of R, it's shared between the two figures. So it must be the same according to the reflexive property of congruence. There you go. So we do have two sets of angles, so I can say that the triangles are similar to each other by the angle-angle similarity postulate. Now looking at the other figure here, I know that angle L and angle ONP are the same because they're given to me. Well, if the angles are the same and the lines or segments MN and OP are similar or parallel to each other, then we must be able to draw the conclusion that angle LNM and angle P are also congruent to each other because they're corresponding angles, just like L and angle ONP are. So we do have, let me go ahead and put that on here, that angle right there and that angle right there. We are able to justify that we have two angles congruent to each other in the figures, so the triangles must be similar. So here we go. Here's another way of looking at it. We want to be able to show that the two triangles here are similar to each other. So Go ahead and pause the video and try to determine why the triangles are similar and write it down. And when you're done, hit play again and see what I have as my answer. All right, guys. Now looking at the figure here, the way I'm thinking about it, they're showing me they're showing me that C and F are the same because they're both 90 degrees. Well, I know that angle CDB and angle FDE have to be the same because they're reflexive angles. Oh, I'm sorry, not reflexive, but they're vertical angles. And vertical angles are always congruent according to the vertical angles theorem. So that gives me two triangles that, or two angles, I should say, that are congruent to each other. So I can say that these two triangles are similar according to the angle-angle similarity postulate. Now, here in example 3, we're getting into very classic type of questions. Now, these aren't necessarily, they don't have to necessarily be triangles, and they don't necessarily have to be because of the angle-angle similarity postulate. This is just a very classic question concerning similarity. There's nothing saying that this has to be angle-angle similarity, although that's kind of how they're making it look. What they're saying is because of the way the sun is shining, the angle right here between the lifeguard and the ground where he's looking, or as the sun hits down on him, could create a shadow, and the angle between the chair and the ground, also with the sun, that those are the same, and because the person is standing vertically and the chair is vertically, that they're perpendicular to the ground. So that's how they're saying that's how they're saying the triangles are similar to each other according to the angle-angle similarity. But this is a very classic kind of question with proportions where we're just going to say, well, how tall is the chair in this case? Well, we know that the person, the lifeguard, is 6'4" tall, and he casts a shadow that's 48 inches. Now, there's one thing right away that I'm a little concerned about. They're giving me dimensions or they're giving me lengths in two different dimensions. One's with feet, one's with inches. So, depending on how they want the answer, you may want to think about converting your feet into inches or your inches into feet. It just kind of depends. Now, in this case, we don't have to do much in the way of conversion. We do need to look at it a little bit here. When I'm looking at it, we can say that 6 feet 4 inches is the same thing as 76 inches. So when I write my ratio, I can say x feet over 76 inches is equal to 6 feet over 48 inches. Now, some of you may be saying, well, Mr. Piercy, how can you solve a proportion where the dimensions aren't the same, meaning we have feet compared to inches? Well, when we actually do our cross multiplication, the inches unit simplifies out of the problem. So when we cross multiply, we're going to get, pardon me, 48 inches times x feet is equal to 6 feet times 76 inches. And when I divide both sides by the 48, I'm not just dividing by 48, I'm dividing by the unit, 48 inches. So the top and bottom, inches over inches, simplifies out of the problem, and so I'm just left with my value in feet, which is what they're asking me to find. How tall is it in feet? So I'd have, in this case, a chair that's 9.5 feet tall. And so the last thing here that we're going to take a look at is what would the length of the shadow be? So now we have a new lifeguard, and this one's much shorter than the other one. This one is only 4 feet 9 inches tall. How would we determine the length of that person's shadow? So you're going to set up and solve a similar proportion to what we just saw in the last example. And go ahead and pause the video and try working this problem out. And when you are finished, come back and can see how I did it. All right, guys. Hopefully we have a really good answer here to see how long the person's shadow is. What I did is I just kind of looking at it in the same situation. Now we're looking for the shadow. So I just kind of stole the original image and say, okay, well, we're looking for this now, and the new person's height is this. Well, if I look at 4 feet 9 inches, that's the same thing as 4.75 feet, because 9 inches is 3/4 of a foot. And we already figured out that the chair was 9.5 feet tall. So I'm going to just substitute those values into the proportion where I'm trying to find the length of the shadow now. I'm saying the length of the shadow over the shadow of the chair, which was 6 feet, is equal to the height of the person over the height of the chair. And when I cross multiply and divide, I get 3 feet for the length of the shadow. But that's it for this lesson, guys. Again, it's primarily talking about similarity still, but in this case, we're focusing specifically on triangles, recognizing that if I have sets of two sets of corresponding angles that are congruent in triangles, then we can say that the figures must be similar to each other. Now, this doesn't really work with other polygons. We would need more information than necessarily just two angles. But for triangles, it works really well, and it kind of ties into a little bit with what we did with triangle congruency. But as always, guys, if you have any questions, please make sure you let me know what they are. And until next time, thanks for watching and take care.